Hello everyone, welcome to my YouTube channel. Today's topic is very interesting topic, writing and balancing chemical equations. So let's start from group 1, sodium. If it reacts with oxygen, the product is sodium oxide. Sodium is 1 positive, oxide is 2 negative. So if we exchange the number without signs, we will get the formula. Na2O is this formula of sodium oxide. Now there are two oxygen atom on the left hand side, so we can put 2 here for sodium atoms. We can put 4 here. So this is the balanced chemical equation. All group 1 metals, they can react in the same way with the oxygen to form oxide. Like sodium, potassium also reacts with the oxygen to form potassium oxide, and the balancing coefficients are same. If I represent the group 1 metal as a M, if it reacts with the oxygen, so it will form M2O. So the balancing coefficients are same. So this M represents the element of group 1. Sodium, potassium, rubidium, lithium, they can react with the oxygen in the same way to form group 1 oxides, and the formula of oxide is M2O. Now, if we have a group 2 metal, magnesium, reacts with the oxygen to form magnesium oxide. This is the formula of magnesium oxide because Mg is 2 positive, oxide is 2 negative, so the charges are same. The numbers are different, so if we cancel these, we'll get a formula MgO. There is one magnesium on the left and right hand side, two oxygen atoms, so we can put the two here. Now 2 Mg are there, so we can put 2 Mg. So this is the balanced chemical equation. So like magnesium, all the group 2 metals, they can react in the same way to form metal oxide. And the student can balance in the same way. So if I say that the element of group 2, if it is represented by a letter M, if it reacts with the oxygen, we will get a formula MO. We can balance all the group 2 metals in the same way. So this element is from group 2, or we can say that all the elements having 2 positive charge, if they react with the oxygen, you can balance the equation in the same way. If we have zinc, and if its zinc reacts with the oxygen to form zinc oxide, so we can balance this chemical equation in the same way which we have already used for the group 2 elements. If we have copper, copper reacts with the oxygen to form copper 2 oxide, we can balance this equation in the same way. So all group 2 elements and the elements having 2 positive charge, they can react with the oxygen to form metal oxide, and the balancing coefficients are identical. Now, let's let's move to the next page. Now, if we have an aluminium metal, if it reacts with the oxygen to get aluminium oxide, now the aluminium is 3 positive, oxide is 2 negative. So the first task of the student is to write the correct formula of oxide. So this is aluminium oxide. Now there are 2 aluminium on the left hand side and 3 oxygen on the right hand side. So if we put 2 here, then 3 oxygen on the right hand side, 2 oxygen on the left hand side. So if we want to balance this oxygen, we can put 3 by 2. So if we cancel the 2, then the number of oxygen atoms are same on the both side. But to remove this 2, or to make it a whole number, we can multiply the whole equation with 2. So if we multiply the whole equation with 2, we will get a balanced chemical equation, which is 4Al. Then 3 by 2 times 2 is 3. So 3O2 and 2Al2O3. If we have the boron, which is also the element of group 3, that can also react in the same way to form boron oxide, and the same balancing coefficients can be used for this element. So all group 3 elements and the elements having 3 positive charge, they can balance in the same way, like iron. If it reacts with the oxygen to form iron 3 oxide, so Fe2O3 is the iron 3 oxide, you can use the same balancing coefficient for all the elements having 3 positive charge. Now, if we have the carbon, carbon can react with the oxygen to form carbon dioxide. So this happens when we use the excess oxygen. This is already balanced equation. Carbon can react with the oxygen to form carbon monoxide as well if we use the limited oxygen, and this is the incomplete combustion. Now we can balance this chemical equation. There is one carbon on the left hand side, one carbon on the right hand side. Carbon is already balanced. Two oxygen left hand side, one oxygen on the right hand side. So if we put 1 by 2 here, so 1 by 2 times 2 is 1. So this is balanced equation. But to make it a whole number, we can multiply the complete equation with 2. So if we multiply this equation with 2, so this is 2C. So 2 times 1 by 2 is 1O2. So it is O2 and 2CO. So this is the balanced chemical equation. Now, if we have another element, which is phosphorus, if it reacts with the oxygen to form P2O5, and this is the phosphorus 5 oxide or phosphorus pentaoxide. So there are two phosphorus. We can put 2 here, 5 oxygen. So we can put 5 by 2 here. So if we cancel the 2, we will get the 5. But to make it a whole number, we can multiply this equation by 2. So the final balanced equation is 4p plus 5 by 2 times 2 is 5. So 5O2, then 2p2O5. Now, if you have the formula of phosphorus 5 oxide in a different way, for example, phosphorus reacts with the oxygen to form P4O10. Now, there are 4 phosphorus. You can put 4 here, 10 oxygen atoms. You can put 5 here. So this is the balanced chemical equation. Sulfur can also react with the oxygen to form sulfur dioxide. This is already balanced, and sulfur dioxide is the main component of the acid rain. Sulfur dioxide can react with the more oxygen to make sulfur trioxide. Now there is one sulfur on both sides, 4 oxygen on the left hand side, 3 oxygen on the right hand side. So if we want to make it 3, we can write 1 by 2. So 1 by 2 times 2 is 1 plus 2, 3. But to make a whole number, we can multiply the complete equation with 2. So this is 2SO2 plus 1 by 2 times 2 is 1. So O2 and then 2SO3. So this is the balanced chemical equation of sulfur dioxide with the oxygen to form sulfur trioxide. Chlorine can also react with the oxygen to form chlorine oxide. So this is Cl2O7. You have 2 chlorine on the left hand side. So 2 chlorine on the left hand side, 7 oxygen on the right hand side. So you can make 7 by 2 here. So to make it a whole number, you can multiply with the 2 coefficients. So this is 2Cl2, 7 by 2 times 2 mean 7 by 2 times 2. You can cancel 2, 2, and this is 7O2, 2Cl2O7. So this is the balanced chemical equation in which the chlorine reacts with the oxygen to form oxide. Now, these elements, they can also react with the chlorine to form chlorides, sodium group 1 element, magnesium group 2 element, aluminium group 3 element, then silicon group 4 element, then phosphorus group 5 element. They all can react with the chlorine to form chlorides. So if we react all these elements with the chlorine to form chlorides, we'll get the products like sodium chloride, then magnesium chloride, because magnesium is 2 positive, then aluminium chloride, silicon is the group 4 element, so SiCl4, then PCl5. So these are the chlorides which we make it when all the elements of group 1, 2, 3 up to 5 react with the chlorine. Now we can balance this equation. There are 2 chlorine atoms, so we can put 2 here, now 2 sodium, 2. This is already balanced. Aluminium and chlorine reacts with the form aluminium chloride. So if we put 3 by 2 here, 3 by 2 here, so we can cancel 2, 2, and 3 will be here. So then we'll have 3 by 2 multiplied by 2, we will get a balanced chemical equation. So this is, if we say this is 3, 3 times 2 is 6, then we can make 2, then 3 times 2 6, and we can put 2 here. Now this is the balanced chemical equation. There are 4 chlorines, so we can put 2 here. Okay, now there are 5 chlorines, so if we put 5 by 2 here, 5 by 2 here, then we can multiply the full equation with the coefficient 2. So we'll get 2p plus 5Cl2 and 2PCl5. This is phosphorus pentachloride. So these elements uh, can react with the different elements of the compound to form different type of product. Now let's start the reaction of some elements with the water. Sodium, if it reacts with the water, the products are sodium hydroxide plus hydrogen gas. Magnesium can also react with the cold water to form this type of product, but if we react with the steam, it will give us magnesium oxide instead of magnesium hydroxide. Now there is one sodium, two hydrogen, and now there are three hydrogen on the right hand side. So if we make it two, we can put 1 by 2 here, and then if we multiply with the coefficient 2, here we'll get 2, here 2, here 2, and 1 by 2 times 2, 1. So 2, 2, 2, 1. These are the coefficients of the above equation. Okay, so magnesium react with the steam, cold water to form magnesium hydroxide plus hydrogen. So there are 4 hydrogen on the right hand side. So if we put 2 here, 4 hydrogen, 2 plus 2, 4 hydrogen, 2 oxygen, 1 Mg and 1 Mg. So this is the balanced equation when sodium and magnesium, they can react with the cold water to form oxide. Now these metals can also react with the acids as well. If we have Mg, if it reacts with the hydrochloric acid, metal plus dilute acid, salt plus hydrogen, the product. So there are 2 chlorines, so we can put 2 here, we'll get a balanced equation. Metal oxides, they can react with the acid to form metal salt plus water. So copper is a metal, so we will get copper 2 nitrate plus water. And now we have 2 nitrates, so we can, if we put 2 here, so the number of hydrogen, nitrogen and oxygen atoms, they are now balanced. The metal carbonate can also react with the different acids to form metal salt, water, and carbon dioxide. So metal is the calcium, and we can use the negative part of the acid to make salt. This is calcium nitrate, then water, and then carbon dioxide. So there are two nitrates, so we can put uh, two here, and the rest of the equation is balanced. Now, the then this is the metal, then metal oxide, then metal carbonate, and then metal hydroxide can also react with the acid. So this is acid and metal hydroxide. This is metal hydroxide, salt and water are the product. So the salt is sodium sulfate plus H2O. So there are two sodium. We can put two here, and now two OH and two hydrogens are there. So that's why we'll get a 2H2O. If we use the phosphoric acid H3PO4 instead of sulfuric acid, so the same type of products are obtained. Sodium phosphate plus H2O. Now there are three hydrogen. We can put three here. So three hydrogen and three OH, they will make a three water molecules, and the sodium is already balanced. Now, if we react the metal hydroxide, calcium hydroxide with the ammonium chloride, this is the property of base that ammonium salts, they can react with the base to form salt, water, and ammonia. So the salt is the first part of the base metal and the second part of ammonium salt, which is calcium chloride, then ammonia, and then water. So we have two chlorine, then if we put two here, the two nitrogen atoms are there, two nitrogen atoms are there. Now, if we look at the number of the rest of the elements, uh, 6 times 2 6, 3 times 2 6 hydrogen plus 2 8 hydrogen, so 4 times 2 8 hydrogen, 2 chlorine, 1 calcium, and then number of hydrogen atom are actually not balanced. 4 times 2 uh, 8 plus 2 10, so 6 times 2 3 times 2 6, and then 10. Now this is the balanced chemical equation. Now, if we have another reaction in which the ammonia combines with the oxygen to form nitrogen monoxide plus water, now we have, okay, one nitrogen, three hydrogen. Now here we have, okay, two hydrogen. So if we make it as a 3 by 2, so now three hydrogens are there, three hydrogen, but the oxygen atoms are 3 plus 1, 4. So we can make 2. Now this is 4. Okay, then so we can, if we want to uh, remove this 2 or a whole number, so let's try with 2. If we multiply with 2, okay, so this is actually 2. This is 4. This is 2, and this is 6. Okay, let me write this equation once again and try to balance this. Now, NO plus H2O. Now, if we have a 6 number here, then, okay, 2 number here, and then 2 here, and then 4 here. Now, this is not balanced because number of 3 times 2, 6 hydrogens are there. Here we have 6 times 2, 12 hydrogens are there. So if we want to make 12 hydrogen, we can use 4 here. 4 times 3, 12. Now we have 4 nitrogens, so we can put 4 here. So 6 plus 4, 10. So we can make this 5. So the final balanced equation is 4NH3 plus 5O2, and then 4NO plus 6H2O. Uh, this is the equation in which ammonia reacts with the oxygen to form nitrogen monoxide and water. Let's do some more equations. This is the reaction of iron trioxide with the carbon monoxide. Carbon monoxide is a reducing agent, and that removes oxygen from iron 3 oxide to make iron metal plus carbon dioxide. So there are two irons, so two iron, three oxygen, and then two oxygen. So we can make it like if we make it 6, 3 times 2, so 3 plus 3 is 6, and 3 carbon, 3 carbon. So this is the balanced chemical equation. Now, if we have this equation Cl2 plus NaOH, sometimes this equation will be asked. So sodium chloride plus NaClO3, sodium chlorate plus H2O. So this equation can be balanced by using the oxidation state method. If we look at the oxidation state or oxidation number of chlorine, this is 0, this is -1, this is +5. So here, some of the chlorine atom are reduced and some are oxidized. So 0 to -1, there is a difference of 1 electron. So 0 to +5, difference of 5 electrons. So if we want to make the loss of electron equal to the gain of electron, we have to multiply this with 5. So now the loss of electron is equal to gain of electron. Now balance the rest of the elements. Now there are 5 plus 1, 6 sodium. So you can put 6 here. And now 5 plus 3, 5 plus 1, 6 chlorine. So we can put 3 here. Now these numbers are fixed. Now just to look at the rest of the elements. Now there are 6 hydrogen and you can put 3 here and oxygen is automatically balanced. So this is the balanced chemical equation. Now let's do some uh, combustion equations. Now, if we have methane, if it reacts with the oxygen in the complete, if this is the complete combustion, carbon dioxide and water are the two products, uh, 2 for hydrogen, so we can put 2 here. Now 2 plus 2 for oxygen, so we can put 2 here. This methane can also react with the oxygen when you have the limited supply of oxygen, a poisonous gas carbon monoxide is formed. So let's balance this equation, the one carbon, 4 hydrogen. So we can put 2 here to make it 4. Now 2 plus 1, 3 oxygen. So 3 by 2, 3 oxygen. Then multiply the whole equation with 2 to make it whole number. So this is 2CH4 plus 3O2 and then 2 carbon monoxide and 4 H2O. So this is the balanced chemical equation of combustion of methane. So like the combustion of methane, the rest of the hydrocarbons like ethane, propane, butane, they can also burn in the presence of oxygen, in excess oxygen to make carbon dioxide and water, and they can be balanced in the same way. Now, for the combustion equation, start with the carbon. So this is carbon, 2 carbon. So you can put 2 here and then 6 hydrogen. You can put 3 here. Now 4 plus 3, 7 oxygen. So you can put here 7 by 2. And if you multiply this equation, so to make it whole number, this is the final balanced equation, 2C2H6 plus 7O2 and then 4 carbon dioxide plus 6 H2O. Or you can also balance this equation, 7 by 2 means 3.5. So we can also balance this equation on 1 mole. 7 by 2 is 3.5. So 3.5 O2 and then 2 carbon dioxide and then 3 H2O. So these both equations are acceptable. This is the balancing of ethane on 1 mole. And in this, if we want to make it a whole number, then we can multiply this equation to get this final equation. If we have propane, C3H8, if it reacts with the oxygen, you will get carbon dioxide and water. There are 3 carbons, so you can put 3 here, 8 hydrogen, you can put 4 here. Now 3 times 2, 6 plus 4, 10, so 5O2. This is the balanced chemical equation. Then if we have an alcohol C3H8O, if it reacts with the oxygen, carbon dioxide, and water are the products, so carbon 3, then we can put 3 here. Hydrogen is 4, 8, 4 times 2, 8. Now 3 times 2, 6, and then 4, 10. But we have already have one oxygen here. So 1 plus how many oxygen is equal to 10? 9. So we have to make it 9, 4 and half. So this is the balanced chemical equation. And if you multiply this whole equation with the number 2, you can also get the coefficient 2 here, and then 9 here, then 6 here, and then 8 here. So that will also be a balanced chemical equation. Then now, if we have some different type of equation that regarding the thermal decomposition of metal nitrate. Now, when we normally decompose the group 2 metal nitrate, we will get metal oxide, nitrogen dioxide, which is the brown gas, and oxygen, which relights glowing splint. Now, to make it balanced, there are 2 nitrogen atoms, so we can put 2 here. Now, 6 oxygen on the left hand side, 4 plus 1, 5, and 7 oxygen on the right hand side. So make it 6. You can write 1 by 2. Now the oxygen atoms are balanced. 3 times 2, 6. 2 times 2, 4, plus 1, and plus 4 plus 1, 5, and then 1, 6. So to make it whole number, you can multiply that uh, equation with 2. This is also balanced chemical equation, but you can write like this: 2 MgNO 3 2 times, and then 2 MgO plus 4 NO2 plus O2, because 1 by 2 times 2 is 1. So that's why this is the final balanced chemical equation. So all elements having 2 positive charge, they can be balanced like this. For example, if you have lead 2 nitrate, so this is lead 2 nitrate, and you will get the same type of products: lead oxide plus nitrogen dioxide plus oxygen, and you can balance in the same way. Then there are some reaction in which we'll get the precipitate. So barium nitrate, if it reacts with the sulfuric acid, this is sulfuric acid, we will get a white precipitate of barium sulfate and then nitric acid. There are 2 nitrates, so if we put 2 here, so this is the balanced chemical equation. Barium chloride can also react with the sodium sulfate to get white precipitate of barium sulfide. So if we exchange the radicals, barium sulfate and then sodium chloride, and then if we put 2 here, this is the balanced chemical equation. Now there is another equation in which the iron 3 sulfate, this is iron 3 sulfate, if it reacts with the sodium hydroxide, we will get red-brown precipitate of iron 3 hydroxide and then sodium sulfate. So this equation can be balanced by iron is 2, so if we put 2 here, now sulfur is 3, we can put 3 here. Now, the sodium atoms are now changed. There are 6 sodium atoms on the right-hand side, so we can put 6 here. So these are the coefficients. Now, if we look at the rest of the elements, whether they are balanced or not, iron 2, sulfur 3, sodium 6, sodium 6. And now let's check the hydrogen 6. And 3 times 2, 6. Oxygen 4 times 3, 12 plus 6, 18. So 3 times 2, 6, and 4 times 3, 12, 12 plus 6, 18. So this is the balanced chemical equation. Okay, another equation in which the lead nitrate combines with the potassium oxide to form lead 2 iodide and then potassium nitrate. So there are 2 nitrates. You can directly put 2 here, 2 potassium iodine is automatically balanced. There is a displacement reaction of iron 3 oxide with the aluminium to make it aluminium oxide plus iron. So there are two aluminiums. So if we put two here, three oxygen, and there are two iron, two iron. So this is the balanced chemical equation. Now, if we have aluminium, then oxygen, then water, and we are getting aluminium hydroxide. So let's try this equation. Okay, we have three oxygen, two plus one, three oxygen, but we have three hydrogen on the right hand side, three hydrogen. So if we put 3 by 2, so this is the three hydrogen. Let's multiply with 2. So if we multiply with 2, this is 2Al plus, okay, 2O2 plus, okay, 3H2O, and then 2AlOH whole thrice. Now let's check that whether this equation is balanced or not. Though, so there are two aluminium, okay, two aluminium, 3 times 2, 6 hydrogen, and then 3 times 2, 6 hydrogen, 2 times 2, 4, 4 plus 3, 7 oxygen. So there are 6 oxygen. So we have to increase the number to balance this equation. So if I increase the number like 4Al, okay, then 3 oxygen and then 6 water. Then I think this will be a balanced chemical equation. So you can increase the number to balance this equation. So 4Al plus 3 oxygen plus 6 water, you will get 4 aluminium hydroxide. Now, there are some more equations. The equation in which ammonia combines with the sulfuric acid to form a fertilizer, ammonium sulfate. This is ammonium sulfate. So we have two nitrogens. So if we put two here, this is the balanced chemical equation. Now, if we have another equation in which the sodium nitrate decomposes to give sodium nitrite plus oxygen gas. So two, three oxygens, we can put 1 by 2 here, then multiply with 2 to get final equation. So 2NaNO3, then 2NaNO2 plus O2. So this is the balanced chemical equation. Okay, now the last equation in which the sodium carbonate reacts with silver nitrate to get sodium nitrate plus silver carbonate. Now there are two silver atoms on the right hand side, so we can put two here, two sodium, we can put two here. So this is the balanced chemical equation. Okay, we have another one, sodium nitrite. Nitrogen in the form of nitrite is 3 negative, sodium is 1 positive. So that's why this is the formula of sodium nitrite. It decomposes to give sodium and nitrogen. So there are 3 sodium. So if we put 3 sodium here, but we have 2 nitrogen as well, so we have to put 2 here. Now the sodium are 6, so this is 6 sodium. So these are some chemical equations of IGCSE O level or edexcel, and I have told you that how to write these equations and how to balance these equations. I hope maximum students they will be able to write and balance chemical equations. Thank you.